Let's do a short study on quadrilaterals, which is a closed figure that has four sides. So first what we're going to do is I've already gone ahead and drew pictures of the various shapes that we're going to talk about. And then we're going to go ahead and describe them, and then we're going to write the formulas for the areas of those shapes. So we're looking at two-dimensional shapes that are four-sided in nature, and we're going to use them as we move further in this chapter. So first of all, the first picture is a picture of a parallelogram. A, B, C, D. And I'd like you to help me describe it. A parallelogram. So, parallel. These two sides are parallel to one another. That's one of the truths about a parallelogram. So, AB is parallel to CD. But so are AD and BC, supposed to be anyway, parallel to one another. So the opposite sides in a parallelogram are parallel to one another. Do you see any equal angles? Yeah, angle A is equal to angle C in a parallelogram. So let's write that down. Angle A is equal to angle C. And do you see angle D and angle B? Angle D equals angle B. Also, something that's pretty doggone interesting about a parallelogram is that adjacent angles, or angle A and angle D, are promised to add to be 180 degrees. Here's why. I'm going to extend a line off of this one a little bit. And do you see this angle A right here? This angle right here is called an alternate interior angle because this is a line that is parallel to this line, and they are intersected by a transversal, and alternate interior angles are always equal. Well, if that's the case, if this angle is always this angle and this is formed by a straight line, these two are supplementary angles. So we always know then that angle A and angle D, I'm going to even call that a plus sign, is equal to 180 degrees, and so is angle A and angle B equal to 180 degrees. You know, we can just go on and on and on. These two add to be 180, these two add to be 180. Finally, what somebody did some time ago is figured out that the area of a parallelogram is found by taking its base times a height. The height is the perpendicular distances between the base that you're going to work with. So I'm going to dimension this section right here. I'm going to call this the lowercase letter b, or the base of this parallelogram. If this is the base, then the height must be the perpendicular distance between these two parallels. If I let this be the base, then I would have to use the perpendicular distance between those two. It's easier for me to use these two right here. Okay. Oh, one more thing I wanted to mention to you. What happened is somebody took off this triangle right here and moved it over here. So just transpose that over here, and can you see that when you cut this section off and put it over here, that you'd have a rectangle, and the area of a rectangle is its base times its height. So that's where that comes from. Okay, a rhombus is a parallelogram. So I'm just going to say is a parallelogram. But a rhombus has four equal sides. And that's really it. Everything else is true about it, just like a parallelogram. You know, these sides are parallel, these sides are parallel, these angles are equal, these angles are equal. You know, these two add to be 180, etc. But this one kind of looks like a diamond because, again, all four sides are equal to one another in a rhombus. The area of a rhombus is still the base times the height. Okay, a rectangle. We're used to rectangles, and we're going to use this a lot in some really pretty good applications. But a rectangle is a parallelogram. Again, is a parallelogram. So opposite sides are parallel, right? Opposite angles are equal, right? Isn't this angle equal to this angle? And isn't angle B equal to angle D? So still, opposite angles are equal. And don't these two still add to be 180, etc.? But in a rectangle, all angles measure to be 90 degrees. If that's the case, and there's 4 of them, 4 angles, and they're all 90 degrees, then the sum of the angles in a rectangle is 360 degrees. And now I need to tell you that the sum of the angles in a quadrilateral is always 360 degrees. Okay, the area of a rectangle, still base times the height. All right, a square, it is a parallelogram, it is a rectangle even too, but it's a rhombus as well, so pretty interesting. But we often label the sides of a square by the letter S. And so instead of writing that the area of a square is base times height, what we're going to say is that it's equal to side times side, which is side squared. Again, it is a parallelogram. It just happened, it is a rectangle. It happens to have 4 equal sides. Finally, let's finish with a rhombus for this particular, a trapezoid for this particular segment. And this is not a parallelogram. I'm going to label this A, B, C, and D. And I want you to know that AB, segment AB, is parallel to CD in a trapezoid. So in a trapezoid, there are only 2 sides that are parallel to one another. However, it is still true, therefore, that angle A plus angle D is equal to 180 degrees. And angle B plus angle C is equal to 180 degrees. It's not true that these two, because these are not parallel lines intersected by a transversal. But if those add to be 180 and those add to be 180, the total again is 360 degrees. The formula for finding the area of a trapezoid is 1/2 the height, which is the distance between the parallel lines. So this is going to be the height, times the sum of the bases, base 1 and base 2. So this might be called base 1, and then DC might be called base 2. I think I'm going to make up some numbers here. So let's say that base 1 is equal to 9. I'm not going to put any units. Let's say base 2 is equal to 11. And let's say that the height, the distance between these parallel lines, is equal to 4. So to calculate the area for this trapezoid, you take half of the height, which is 4, times the sum of the bases, which is 9 plus 11. If I was going to do this without a calculator, I would do what's in the parentheses first. 9 plus 11 is 20. Then it says take half of 4 times 20. Again, without a calculator, it would be easiest for me to take half of 4 is 2, and then finally 2 times 20 is 40. But if you type this into your calculator just as you see it like this, 1 divided by 2 times 4 times, and then put open parentheses 9 plus 11 close parentheses, you should get 40. In the next segment, when we come back, we're just going to do some more problems with the areas of these 4-sided shapes.